Hi everyone. Today we're going to be talking about interval notation and domain and range. In order to understand domain and range, we're going to go back to something that we were supposed to learn about in first trimester, but we never got around to it. So first, we're going to discuss interval notation. When you were in 8th grade and you saw a problem like this right here, you would have written down that the answer was x is greater than or equal to 2. How did we get that? Well, this is 2. The closed circle is telling us it's the greater than or equal to. And the fact that it keeps going is telling us that it's going to go to 10. It's going to go to 100. It's going to go to 200 and 500 and 1 million. It's going to go all the way to infinity. Okay, so how does that relate to interval notation? Interval notation, in my opinion, is a little bit easier to understand what you're talking about than doing inequality notation, or at least I like it better. Okay, so what does it mean? Well, the first thing that we do when we talk about interval notation, we say what is the lowest number that x can be. Okay, and x is talking about whatever variable or whatever number it is. Okay, the lowest number that x can be is 2. Hey, guess what? It also could be 3. It could be 4. It could be 5. It could be 6.5. It could be 9.1. It could be I don't know where I am now. It could be 11.1. There's lots of different numbers that it could be, but it also keeps going to infinity. That's what that arrow means, is it goes to infinity. So I have my lowest number that x can be, which is 2, but then my highest number that x can be is infinity. And that's not really a number, but it's saying that's the highest it can be. Then we ask ourselves, and I'm just going to teach you what this is because you've never seen it before, but when I want to say that it's equal to, like this was equal to, so we put an equal on here. Well, how do we show it on this interval notation? We put what's called a bracket. Now, how do I remember that it's equal to? There's my equal sign right there. Okay, it's like a parenthesis with an equal sign. Now, can I be equal to an infinity? No, because infinity is not a number, so I put a parenthesis. Now, I know that looks all crazy. How would I write it without all the lines and stuff? It would be 2 to infinity. That's saying that my values of x could be anywhere from 2 to infinity. Okay, let's look at this next one here. This one's a little bit backwards. Okay, so we're going to do the same thing. We're going to ask ourselves, what kind of values could we have for x? So this one right here is -4. It could be -5 or -6 or -9.1, or it could be -11.4. But there's lots of different values. This arrow is telling me it's going to infinity. But I have to distinguish between the fact that over here it was going to infinity. On this side, it's going to the negative numbers infinity. So I'm going to call that negative infinity. So when I write my interval notation, same thing. Lowest number and then highest number. Okay, so my lowest number that it could be, negative infinity, even though that's not a number. And then the highest it could be is -4. So it's saying my values for x could be anywhere in between negative infinity and 4. Is it equal to -4? Yeah, because it's got that filled in circle there, so we're going to put a bracket around it. And then is it equal to infinity, negative infinity? No, it can't be equal to negative infinity because that's not a number. Okay, so what would that look like without all the lines and stuff? My actual answer would look like this: negative infinity to -4 bracket. Okay, next one. This time I'm going to give you the interval notation and I'm going to ask you to draw it. Okay, you can pause the video and do that. Okay, we're going to go ahead and start. Negative infinity, that's telling me that, hey, my answers are down here on the negative side and it's got that arrow there. I'm going to put a dot on 5 because that is the highest my answers can be. So this is your highest number, this is your lowest number. My parenthesis right here is because that is not a number. I can't be equal to it. But right here, this is a parenthesis. That means it's not equal to. So I'm going to leave this right here as an open circle. And then I am going to say that all of those numbers in there could be a value. It could be 0, it could be -5, it could be -3. All of those values are part of it. Now we're going to look at it a little bit different. Okay, this time I don't have an arrow. I have a closed circle on this end, and I have an open circle on this end. Okay, I actually think these are a little bit easier. So what is the lowest number for my values? It is -10. What is my highest number? Well, it's 0. So that's my highest number. This was my lowest number. Can it be equal to this one right here? Well, yeah, it's got that closed circle. Remember, the equal is your equal sign right here. And then is it equal to 0? No, so that is a parenthesis. I'm going to go a little bit faster on the next one. Okay, so it's telling me right here, this is my lowest number that it could be, so -2, and I'm going to put an open circle because of the parenthesis. This one is telling me that it is a closed circle at 5, so right there. And all of those values in between there are values that work for that number line right there. It means that, hey, 0 is a value that works there, 2 is a value, all of them. Okay, so this is just kind of a summary. You can pause it, you can take a picture of it, do whatever, but there is a summary for you of, hey, brackets. These brackets right here mean equal to, they're a closed circle. The parentheses mean not equal to, they're an open circle. When you use the infinities, you're always going to use parentheses. Okay, now how are we going to use this? We've talked about domain and range before. So what is the definition of domain? It is all your possible x values, okay? Every x value that works in a function, okay? What is your range? Well, it's all your possible y values of a function. What is that going to look like, okay? So let's remind ourselves back, we did this a little while ago, but domain. When I taught about tennis balls. I'm going to put a tennis ball on each of these dots here, and hopefully this will remind you what we did for domain. Okay, so there's my tennis ball. And then my x-axis was like the surface of water. Well, what does a tennis ball do on the surface of water? It floats. Okay, so here I go. I'm going to float these. And this is telling me what are my possible x values in this equation. Well, it is -3, and it's -1, and it's 0, and it's 2, and it's 4. How do I write that? Well, I use those little curly brackets things that I'm not very good at drawing. -3, -1, 0, 2, and 4, and I put my curly bracket. That's telling me that each of those are separate, distinct points, but these are the only x values that are in that function. Okay, now what we're going to do is we're going to do the y ones. Okay, so let me get these out of the way. Okay, we're going to bring over the Angry Birds this time. And when I do the Angry Birds for my range, I think of my building here as it's a bird, a bird flies into a glass building. So here we go. The bird smashes, it smashes. Have you ever seen that happen? They smash into buildings. So now when I do my y values, what is the lowest value for y? Well, it's -2 right here. Then it goes 1, and then it is 3. Okay? There's no repeats because those birds landed in the same spot. So here we go. -2, 1, and 3. So those are the only values of y in that function. Is this discrete or continuous? It's discrete. Well, we've done the discrete ones before, so now what we want to talk about is the continuous, and this is why we talked about the integral notation at the very beginning. So you can kind of think of the same thing. Let's do our tennis ball again. Okay, I'm going to put a tennis ball at each end of this. And it's like there are tennis balls all along this line because every value in between those tennis balls is a value in this function. Okay, and then what happens, and I'm not going to draw the whole thing because this could take me forever. I'm going to show you a different way to do it, but I'm going to still think of this as my surface of the water, and I'm going to drop my tennis ball down. And imagine that there is a whole bunch of tennis balls. I wish I could do it really, really fast, and it would be really cool in a video, but all of those tennis balls kind of just, move around. And there's more tennis balls right along in here. Okay, so what does that mean? I like to just say, well, I've got an open circle here. Do you see how I just brought that up? I've got this closed circle here. And then it's a string connecting them in the middle. every value, I probably should have used green like a tennis ball, but every value in between this, which is, let's see, -4, and this, which is 4, is an answer, or is an x value in this function. Every x value in between there gets touched, okay? So then we ask ourselves, my lowest value is -4, my highest value is 4. Can it be equal to 4? Well, no, this open circle is telling me it's in parentheses. Can it be equal to this one? Yeah, the closed circle is telling me it's equal, so that's where I do the bracket. Okay, so now I'm going to erase this mess of a thing right here, and I'm going to try to get my tennis balls out of the way. And we're going to use the same idea, but this time I'm not going to bring the Angry Bird over. I'm just going to give you my other suggestion. Okay, this is like your Angry Bird. Bring it over here and put your open circle right here. Here's your Angry Bird. Bring it and put it here. And then you've got the string connecting them. Well, what that's saying is on this function, it is going to touch every y value between -3, because that's your lowest value, and 1. Every one of them gets touched, okay? So what does my range look like? -3 is the lowest value, 1 is the highest value. It's going to be parenthesis because of the open circle, and it's going to be a bracket because of the closed circle. Is this discrete or continuous? Continuous. Okay, we're going to go a little bit faster on the next one. Hopefully, you kind of got the idea on that last one. Okay, we're going to do the same thing. Drop your tennis ball down. Here's my tennis ball. This arrow is going to be like a tennis ball, but we're going to make it an arrow, and then we've got the string connecting it. So, does this look familiar to the ones we did at the beginning? Hopefully it does. What does this arrow mean? It means it's going to -infinity. What does this one mean? It means it's going to 4. So every value in between -infinity and 4 are x values in this function. Is it equal to -infinity? No. Is it equal to the 4 because it's a closed circle? Yes. Now we're going to do the range. Okay, I'm going to bring my arrow over. I'm going to bring my dot over. And then I'm going to draw the string in between it. So the arrow here is telling me that it's going to -infinity. This one is telling me it's going to 1. So every y value in between here is going to be a value in this function. So -infinity is the lowest. 1 is the highest. It's not equal to -infinity. It is equal to 1. This is a continuous function. Hey, you should probably pause the video now and see if you can figure this one out. All right, hopefully you had time to figure it out. So here we go. Treat this like a tennis ball. I'm going to bring my arrow up. I'm going to bring my arrow down. I'm going to draw the string in between it. Hey, what does this arrow mean? Well, this one means -infinity. What does this arrow mean? It means my answers are going to go to +infinity. And everything in between them is a value for x. So that is part of my domain. So -infinity to infinity. Hopefully you remember that we talked about that you cannot be equal to infinity or -infinity. So those are both going to be parentheses. Now we're going to do range. Bring your arrow over. Bring your arrow over. Draw your string in between them. Okay, what's the lowest that y can be? -infinity. What's the highest it can be? Infinity. That means it's going to touch every y value in this function. Okay, it's going to keep going. It's going to touch all the y values. And this is continuous because it is a line. Okay, now we're going to look at an exponential one. So you have to remember what we talked about a couple days ago. I'm not sure where you were, but first let's do our domain. You've already got this arrow right here, so we don't need to really drop it down, but we do need to drop this one down. Okay, so when we look at our domain, we have got -infinity to +infinity. It means it's going to touch every x value. Okay, now I'm going to erase this time. I want you to think about asymptotes. Where is the asymptote on this? And I'm just going to draw it in. I've got an asymptote right here at y = 0. And that's telling me that this equation is going to get close to 0, but it will never, ever, ever cross the line. This is like a fence right here. Okay, so imagine a fence. Is it going to touch the fence? No, it's not going to touch the fence. It's going to get really close. So what I have to do right here on my range, because it's never going to cross that, is I'm going to put an open circle. It's going to get close to it. It's never, ever, ever going to touch it or cross it. Now I'm going to bring this arrow over right here, and I'm going to draw my line. So now I look here and say, what is the lowest my y value can be? 0. It's never going to go below that. And then what's the highest it can be? Well, that's a positive infinity right there. Okay, can it be equal to the 0? Well, it can't. It will never touch that fence, so I'm going to have a parenthesis and a parenthesis because that is an infinity. This is continuous. We're going to do one more of those because kids tend to struggle with the asymptote part of this. So do your domain first. Okay, this is going to keep going out this way. This one is going to keep going out that way. So here we go. We got our little arrow. We got our arrow. I should have brought it to the x-axis. Sorry, I messed up on that. So that means it's going to go from negative infinity to positive infinity. It will touch every x value. But the y values are a little bit different. Where is the asymptote? Okay, so my asymptote is right here. So this time my fence, remember this is your fence, your asymptote, it's going up to that and it's not going to cross it. Okay? Put your open circle on your fence. Okay? It's not going to touch it. It's like an electric fence. It will be close to it, it's not going to touch it. This is an arrow right here. So it's saying that it's going to touch every y value below that fence, but it will never go above the fence. So what's the lowest it can be? Negative infinity. What's the highest it can be? It's going to be, let's see, 1, 2, 3. Okay, and it's going to be parentheses there because of the open circle, it's parentheses there. It is continuous. So let's do a little bit of a summary. First, when do you use curly brackets? We only did one example of this today because we've already learned it, but curly brackets are on discrete graphs. That's when you're labeling individual points that are part of your domain. When do you use interval notation? When you have a continuous graph because it's saying, hey, I don't want to list this point and this point and this point and this point and this one, this one, this one, this one, this one, this one, this one. I just want to say it's between here and here. Okay, so now let's do one more. This is going to be one that's maybe a little bit more challenging, but we're going to do the same idea. Domain. Drop down your tennis ball. A lot of people consider this a tennis ball. We can drop that down too if you want, and then this one is a tennis ball. But what's in between them? A string. That has a string right there. That has a string right there. It's saying that between here and here, does every x value get touched? Yeah, it does. Okay, so the lowest it is -4. The highest it is 5. Is it equal to -4? Yes. Is it equal to 5? Yes. Does it matter that it went up and down? No, it doesn't even matter. It's just the fact that it touched every x value between them. Okay, so now we're going to look at our range. Okay, right here, I'm going to bring that over. I'm going to bring this one over. And I'm also going to bring this one over. And then you've got your strings in between them. Okay, now, it's telling me that the lowest value, so you can see right here, because that's the lowest it goes on the graph, is going to be -3. What is the highest my y values go? Well, they go right here, which is, let's see, that is 4. Okay, so the lowest it is -3. The highest it is 4. Is it equal to 3? -3? Yes. Is it equal to 4? Yes. Okay, and that hopefully is enough to get you going on domain and range.